Imagine this for a second. You're out on the deck of an LNG carrier, miles from shore, or maybe you're deep inside the heart of a petrochemical plant, just surrounded by this hum of machinery.
These are places where there is absolutely zero tolerance for failure.
Exactly. And now the nightmare scenario. You've got to do some critical maintenance, but a key fastener on, say, a high-pressure flange is just seized, has welded itself shut.
And that one moment when a simple job turns into a battle with torches and grinders, that's where the real cost of industrial failure is. It's not just about the big engines. It starts with the nuts and bolts.
And that, right there, is the core of our deep dive today. We're talking about the unsung hero of industrial uptime, specialized anti-seize compounds. Specifically, we're going to be dissecting the engineering behind Jet-Lube 49704, their marine-grade anti-seize. It's basically an elite insurance policy for your most critical equipment.
And our mission here is to really give you a shortcut to understanding this. We want to go beyond just, it stops rust. We're going to unpack the specific threats, chemical, electrical, and see why standard lubricants are actually a huge liability.
Right, and why a purpose-built product like this one prevents those shut-it-all-down panic modes.
Because choosing the right compound is what separates a smooth operation from a very, very costly shutdown.
Okay, let's jump right in then. Let's define the enemy. So let's unpack this. We have these environments that are, they're actively trying to destroy every single joint. So why can't a big facility just, grab a cheap bucket of all-purpose grease?
The environment just demands a completely different class of product. In heavy industry, you're really up against three main threats that generic lubricants just cannot handle.
Okay, three threats. What are they?
First up is galling. This is a huge, huge problem with stainless steel fasteners.
Yep.
When you tighten them, the surfaces are under such immense pressure that they basically cold weld together. The friction and heat cause the metal to transfer, and boom, it's seized.
And a standard grease just gets squeezed out or breaks down.
It can't handle the pressure. So that's the mechanical problem. Then you have the chemical one.
Which is the obvious one, corrosion,
Yeah.
salt, water, moisture, that kind of thing.
Right. The second threat, most standard products, even ones that say they're water resistant, they just wash out, or they emulsify, they degrade, and they leave the bare metal exposed.
But hold on, isn't that just a water resistance issue? What makes a marine environment so much worse than just a really humid factory?
That's the critical question. And it brings us to the third and maybe the most important threat, galvanic corrosion.
Okay.
Which is massively accelerated by electrical conductivity. This is where most generic anti-seize products fail spectacularly.
Because a lot of those standard compounds, they have metal flakes in them, right?
Yeah.
Copper, aluminum.
Exactly. And that's the liability. So imagine you have two different metals. A stainless steel bolt going into a carbon steel flange. You add an electrolyte salt water, and you've just created a battery.
Yeah, the natural battery.
And the less noble metal gets sacrificed, it corrodes away. Now, if your anti-seize is full of metal particles, it's electrically conductive.
So you've just completed the circuit.
You've created a perfect low-resistance path for the current to flow. The anti-seize isn't just failing to protect it, it's actively helping the corrosion process.
It's making it worse.
Yeah.
Exponentially worse.
Exactly. You don't just find a little rust. You find fasteners that have basically turned into powder. And it's not a slow process. It's rapid decay, and it's fueled by the grease itself. That was the huge technical barrier to overcome.
This is where it gets really interesting, because we understand the threat now.
Yeah.
So how does something like the Jet-Lube 49704, the marine grade, actually conquer these challenges? What's so unique about its formula?
The whole engineering focus was on one thing: absolute chemical and electrical isolation. It is explicitly a non-conductive, non-metallic blend. And that's not just a minor tweak, it's a fundamental shift away from traditional anti-seize.
So when you say non-metallic, what are we talking about? What are they using instead of copper or aluminum?
You're talking about highly inert, really durable anti-friction solids. Think specialty ceramics, maybe some graphite, other engineered polymers. The whole point is that they are chemically stable, and most importantly, they're electrical insulators.
So that non-metallic nature is what you said slams the door shut on galvanic corrosion.
Precisely. By using these non-conductive fillers, the compound physically breaks that electrical circuit between the two metals.
It can't form the battery.
It can't. So the protective film stays stable, it doesn't wash out, and it creates this long-lasting insulating barrier. It stops the current flow entirely, and this performance is built to meet and, often exceed really tough military and marine specifications.
It's an interesting way to think about it. You're not just lubricating. You're applying a stable, electrically inert protective film.
That's the real benefit here. This specific formulation resists saltwater, it resists moisture, it resists those crazy temperature swings you get in engine rooms or on piping systems.
It's like an incredibly stable barrier.
It is. It prevents rust, corrosion, and galling for the long haul, even under intense pressure.
And the practical outcome of that is huge. You're extending equipment life, you're cutting down on maintenance. That's real peace of mind.
Absolutely. Think about your high-value assets. Valves, flanges, anchor systems. They need to work for decades. If you protect that critical joinery, you are injecting longevity right into the core of your asset, and you're minimizing the risk to people who have to do that dangerous maintenance.
But we shouldn't let the marine name fool us.
Yeah.
I mean, if the 49704 is built for the ultimate water challenge, this kind of thinking must apply elsewhere.
That is such an essential point. The lessons learned in that aquatic battlefield, they've been adapted for almost every heavy industrial environment you can think of.
Wherever temperature or unique chemicals are the main problem.
Exactly. The engineers at Jet-Lube realized that you need different shields for different threats. It's not a one-size-fits-all problem.
And the challenges get a lot bigger when you introduce extreme heat.
Hmm.
The 49704 is great for moisture, but what happens when you're getting close to combustion temperatures?
Right, and that's where you need a totally different product like Jet-Lube Nickel. This one is a premium nickel-based formula.
So not non-metallic.
Not at all. Nickel is designed for scorching heat. It can protect components up to, I believe, 2,400 degrees Fahrenheit.
2,400 degrees.
True.
That's staggering. Where would you use a nickel compound over the marine grade one?
Nickel just has incredible structural stability at those extreme temperatures where the solids in a composite grease might just burn off.
Okay.
So nickel is for things with severe thermal cycling. Turbine bolts, exhaust manifolds, high-pressure boilers in power plants. It creates that reliable barrier against seizure when things are expanding and contracting like crazy from the heat.
So nickel is the answer for thermal stress, not necessarily saltwater corrosion.
Different tools for different jobs. And then you have other products like for environments with extreme mechanical load and just high water resistance, not necessarily constant submersion.
You mean something like the Jet-Lube 550?
Yes, exactly. The 550 is highly water resistant and it's formulated for really rough thread conditions or on things with heavy vibration.
So like big construction rigs or manufacturing presses.
Perfect example. Huge earth-moving equipment, things that deal with grime, dirt, and heavy washdowns all day. It just expands that universe of protection to make sure fittings dealing with intense wear are protected.
Let's broaden this out a bit. Outside of oceans and heavy machinery, where are these compounds making a difference every single day?
Well, take a refinery or a petrochemical plant. They're not fighting waves, but they are fighting these incredibly aggressive internal environments.
Like chemical fog or steam?
Brine, high concentrations of sulfur, you name it. These specialized compounds protect vital valves, tanks, pump assemblies, anything in those severe chemical environments, making sure critical systems can always be maintained.
What about utilities, where you have humidity, maybe flooding, or even just powerful cleaning chemicals as part of the daily routine?
Absolutely. This kind of assurance keeps cooling towers, electrical conduits, heavy manufacturing lines. It keeps them all running despite that constant exposure. The real takeaway is that this level of reliability, it scales from the tiniest little screw to the biggest structural bolt.
Okay, so if the product generally offers that kind of specialized protection, we have to talk about the bottom line. What does this mean for a CFO, for an operations director? This goes beyond maintenance. It's a straight-up business decision.
It really is. And this kind of specialized product, it pays for itself. Often in the very first maintenance cycle where it's used. This is the ROI case you can take right to the boardroom.
Where do you see the biggest savings?
The first one is all about time to repair. We call it rapid installations and zero hassle removal.
Okay.
When a facility is in a maintenance window, every single second counts. So being able to loosen bolts and pipes effortlessly without damage saves a huge amount of man-hours.
No stripped stainless steel, no cutting torches.
No torches required, less risk of damaging the components around it. That speed translates directly into avoided downtime, and that means recovered production.
That speed is obviously critical, but I'm guessing the long-term protection against the asset itself degrading also has to be a huge factor.
Oh, absolutely. That's the pure profit part of it. Because the compound acts as this impenetrable shield against saltwater chemicals, humidity. The useful life of your expensive valves and flanges is just dramatically extended.
Right.
If you can add even a few years to the life of one critical valve assembly, that return on investment justifies the product for the entire facility.
And then there's the whole regulatory side of things, especially in marine and energy, where the standards are just incredibly high.
That's a huge point for risk management. Using a marine formula that meets those tough environmental mandates gives you peace of mind that you are operating within spec. It minimizes environmental risk and ensures compliance.
Which is non-negotiable today.
It is. And finally, you have the efficiency of your maintenance team. I mean, fewer headaches means a more effective team.
True.
By getting rid of the root cause of fastener failure, you fundamentally cut your maintenance needs. You shift from, emergency firefighting to planned, productive work. Your team is more efficient, and you buy fewer replacement parts.
So for the procurement teams that are actually tasked with getting this stuff, who stocks this at the kind of volume they need?
A specialized product requires a specialized supply chain. Sources point to expert industrial suppliers like a PEnergy.com. They're not just general supply houses. They specialize in having deep inventory of brands like Jet-Lube.
And they offer the technical expertise to go with it.
Exactly. They're a solutions provider. They make sure that the procurement teams get not just a product, but the right product for their specific challenge.
So we've definitely established these are not commodity products. They're engineered for high pressure, for huge temperature swings, caustic chemicals, crushing loads. This is not, hobby store goop.
That really is the core synthesis. Reliability and longevity in these critical industries, it's only possible when you treat your fasteners and your joinery with the same respect you give a multi-million-dollar turbine engine.
It is a vital investment.
It's an investment in maximizing the performance and the lifespan of your assets. It's a direct investment in reducing your operational risk.
Indeed.
I guess to leave you with a final thought to mull over, you would never put low-grade diesel in a high-performance million-dollar engine, right?
Of course not.
Yet so many businesses still gamble with commodity grease. Every single busted bolt or seized valve can cost a small fortune in labor, lost production, replacement parts, a cost that can be thousands of times more than the initial investment in the right product.
So the question is,
why? Why do businesses still gamble like that when the price of preventing just one of those failures would easily justify the cost of high-grade assurance for an entire year? We'd encourage you to explore the full range of options out there that deliver proven, measurable reliability.